Hello, today's topic is slightly offbeat. So the topic for today is elastic properties. So it says the breaking stress of steel is, so let us say it is the breaking stress of steel. Steel is equal to 8 into 10 power 9 Newton per meter square. So we have to find the greatest length of a steel wire that can hang vertically without breaking. So what happens is, when we suspend a certain weight, the weight of these things put a stress on these things. So as you go on suspending more and more, the weight of a lower part will be putting more and more stress on the molecules of the upper part. So that's what it is saying. And ultimately, if the weight is very high, it might exceed the maximum breaking force that it can hold. So it can withhold. So that's why there is a certain limit to the length of that thing which can be supported, and after that it will break. So that's what we have to find out here. So we have a row of steel. Steel is given as 8,000 kg per meter cube. So let me represent the vertically hanging steel wire as this. So this is the steel wire, and let us say that right now it is at the maximum length. So this will be, the length will be L max. This is the cross section. This will be the cross section A. So what we have here is, so let us say L max is the maximum length it can hold. So if so, then if L max equal to maximum length that can be supported, then the max volume V max will be equal to cross sectional area A into L max. So volume is equal to area, cross sectional area into length. This gives us maximum mass, let us say M max is equal to rho into V max. So it will be equal to rho into A into L max. Now if you go further, then the maximum weight, which we call as W max, so it will be equal to mass max into G. So that's equal to rho into A into L max into G. So this is the weight max. Now the string or the steel wire. So the steel wire will snap when its weight just exceeds the breaking force. So that is I can say this weight max is equal to breaking force of steel, and this will be equal to, so if I use the data here, or rho into A into L max into Z will be equal to, the relation between breaking force and breaking stress will be equal to breaking stress of steel into A. It's because force is equal to stress into area A. So here I can cancel this A and this A. So it will give us L max is equal to, so BS of steel divided, we have a rho into G. So the quantity in the numerator is 8 into 10 to the power 9. The value of rho is, it is 8,000 into the value of G is for ease, we'll be using the value 10 here. So if you use 9.8, it might give some other value. So if we take 10, it will give us some proper representable values. So that's why. So if I want to calculate it, it'll give me, so 8 exponent 9 divided 1000. So this equal to it is 10 to power 5 meters. So this will ultimately come out to be equal to, I can also say it as, it is 10 to power 2 kilometers. So it is 100 kilometers. So if we suspend 100 kilometers of a copper wire vertically, then it will just snap, or it will just break down under its own weight.